Okay, welcome to today's topic. Today we're going to be talking about imaginary numbers, and then we're also going to talk about complex numbers in the video after this, although this one is just on the imaginary part of it. So the last videos we just watched, or we've been talking about in class, one or the other, is finding the square root of numbers. And so if you go to find the square root again of, let's say, 9, we can do that because I can take 3 times 3, and that'll give me 9, right? So then the question becomes, okay, but what happens if I want to take the square root of a negative 9? What number can I take times itself, okay, and get a negative 9? Okay, well, the answer is there's no number that I can take by itself and get it negative. So, mathematicians had to figure out a way to get past this, because if this was the case, what we would say is no real solutions. Now, what I mean by that is at the beginning of the year, one of the first things that we started talking about was we said, okay, we got our counting numbers, you've got your whole numbers, you've got your integers, you've got your rationals, you had your irrationals, which were like pi, and we said every one of these were real numbers. Okay? So when I say no real number, what I'm saying is there's nothing in here. No integers, no rational, no irrational, no nothing that will work for this problem. And so what we do is we add a whole nother set over here. Okay? And this new set that we're going to add in are called the imaginary. Well, let me back up. They're actually called the complex. And imaginary is just a part of that. Complex numbers. Okay? And imaginary is a piece of that. Okay? So we're talking now a whole nother area of stuff. Okay? So that's why we say no real numbers. So again, back to what I was saying. Scientists, or mathematicians, not scientists, I hope, but maybe scientists, had to come up with something. And so since we know we can take the square root of 9, they said, well, if I just take out and break this apart and do the square root of a negative 1 times the square root of 9, now I can do this piece. Okay, that I can do. So then we're going to okay, well, we could just write the square root, we could write this as 3 times the square root of a negative 1. Okay, well, we could stop there. But they said, let's not stop there. Let's go a little bit past that. And so what we did was we defined the square root of a negative 1 as simply I, meaning imaginary number. Okay? And then we will see, and later on when we do our complex numbers, if you're starting to multiply imaginaries, then we had to have something more than just an I to the first power. And so then we start talking about, well, what happens if I take I and I square it? Well, let's just do what we've had there. We had the square root of a negative 1. And if I square, now be careful with this, if I square the square root of a negative 1, remember square and square root are opposite operations. They cancel out, and I would get a negative 1. If I do I cubed, well, I could think of it several different ways, but I could think of it as an I squared times an I1, which would mean I have an I squared, which is a negative 1 times I, and so I cubed actually can be simplified down to a negative I. Okay? Then what if we had 4 of those? Well, again, you can do that several different ways. I like doing I squared times I squared because I think that's an easy one. I squared was a negative 1, so a negative 1 times a negative 1 is a positive 1. And we could continue that process. If I had I5, well, let's do I5 as an I and an I4. Well, I is just I, and an I4 is 1, so I5 is I. And if you can keep up this pattern, or this go I6, I7, I8, so forth, what you're going to see is that it becomes a repetitive pattern. And it repeats after every 4. Okay, so I6 would be the same as I squared. I7 would be the same as I3. I8 would be the same as I4. And so we really only need to know the first four. So I'm going to rewrite this a little bit neater, and I'm going to say I is the square root of a negative 1. I squared is a negative 1. I cubed is a negative I4 is 1. And that piece right there you need to know, okay? Whether it's a memorization or know how to compute it yourself, but that is something you need to know, okay? So let's go on and do this within a problem then. So we're going to do this just like what we did the last problems. We're just going to simplify our radicals. But again, it has a negative in there. So the first thing that I'm going to do is I'm going to say, well, that's a negative 1, square root of a negative 1, and now square root of 16. So the square root of a negative 1 is I. Square root of 16 is 4. And now here's another thing. They kind of, an unwritten rule, if you want to call it, is they always put the I second, okay? And this is where it comes into our complex numbers, okay? Complex numbers simply means that I have a part that sometimes has a real part and sometimes it has an imaginary part with it. So we call it A plus BI, okay? So it's a real part and an imaginary part. So this would be a real number and this is your imaginary number, okay? It's called a complex number, okay? We're going to see that when we start solving our quadratics. You're going to see that. So let's just do another one here. Square root of negative 1, square root of 200. I'll write all the steps in. You can shorten it. Square root of a negative 1. Again, now I'm going to find my perfect square that's in 200. That one's an easy, 102. Square root of a negative 1 is I. Square root of 100 is 10. And the square root of 2 is as low as it'll go. Now, again, what I told you earlier is that they usually write it as, and by the definition, this way. Okay? That's how it goes by the definition, A plus BI. Here's the thing. There's not a problem with that. That is 100% correct. But what happens a lot of time that becomes confusing to teachers, maybe even confusing to kids, is that this radical sometimes gets extended, okay? They might extend it out a little bit, okay? And so that it ends up looking like that I is underneath the radical. And because of that, the way we typically see it in textbooks and so forth, and how I would like for you to write it, is 10I square root 2. Now, not to say 100% of the time that that's how your textbook is going to write it, but it's very common practice for it to be written that way so that that I is distinctively out in front of the radical and not under the radical. Okay? So, remember that. Okay. When you see a multiplication with this, you do need to break it apart. Okay? Negative 1, 4, negative 1, 9. So the square root of a negative 1 is I. Square root of 4 is 2. Square root of a negative 1 is I. Square root of 9 is 3. Okay? 3 times 2 is 6. I times I is I squared. But I'm going to go back up to my chart, and I know I squared is a negative 1. So this is a negative 1 times 6, which would be a negative 6. Okay? Be very careful with that. A lot of times what happens is kids want to take these and multiply them together. That will work. Listen to the rule. That will work, but only if those are both positives. You may not just multiply underneath if one or both are negatives. Okay? Okay, next step over here is just 2 times the square root of a negative 4. So that's 2. Square root of a negative 1, square root of 4. That would be I. Square root of 4 is 2. 2 times 2 is 4. I. Okay, Now, I know some of you are thinking, well, I don't need to do all that work. No, you probably don't when they're perfect squares. In other words, if you look at the square root of a negative 36, most of you can write for me 6i. 100% okay. Okay? But again, you need to be able to justify it as I did on 1 through 4 if asked to. Now, number 2 goes back to what we did on the last video when we were simplifying radicals, because now 162 is not a perfect square. So what I need to know is which one of my perfect squares, okay, will go into 162. Again, that's that list we talked about before, 1, 4, 9, 16, 25, so forth. Which number will go into 162? And a lot of you already know it's 81 and 2. So again, especially if you're in honors, if you need to skip or want to skip and call this 9i radical 2 and go straight to that part, I'm okay with that. Some of you need the extra step. If you do, please put it in. Okay? And I'll leave those last 2 for you to try on your own. So finish those last 2 out. Don't wait for me. Be sure you have those done. You'll be expected to possibly answer those in class.